Hello and welcome to ET Auto. I'm Shazil and I'd like to tell you that air taxis in India is soon going to be a reality. That's what the startup Sarla Aviation likes us to believe. We have the CIO and the CEO of the company with us. Hi Adrian.
Hi.
And hi Shivam. So we'd like to understand about you first. What are your backgrounds? What is the product like? And what is the intent behind the product?
Okay, so my background is in the automotive industry. I'm a big fan of your outlet. I have worked in the German car industry for most of my career before I pivoted and then started working in flying taxis. So I worked with flying taxis in Europe, and then we came here to build Sarla Aviation.
You Shivam?
Yeah,
Please tell something about
yeah.
yourself.
I'm Shivam, CIO of the company. I have a background in electronics and software, and that was most of it. Even today, that's what I'm handling at Sarla. I think previously, starting at Sarla, I was at Joby Aviation, one other eVTOL company in California, and we understood a lot of details about this product and a market, and then we all decided to do the same thing for India.
So you just said that this product has been developed in under a year. That's quite fascinating. Can you please to tell us something about the product?
Sure, it's a fully electric eVTOL aircraft, aka air taxi. We have the world's largest cabin. All the other players in the globally, they have 4 passengers, 1 pilot, and we did 6 because we knew that Indian market they focus a lot on affordability, and we want to operate in India. So that's our core, and that's what it is here. And we are building out of Bangalore. It's fully designed, developed, manufactured in India, and we are very happy about it.
So is it like a customizable option? Is there?
Yeah, totally. I mean, see, like how we look at this is basically we give you 680 kilograms of payload. If you place passenger seats inside of that, that's cool. If you want to place cargo in that, that's also cool. Anything is possible. What we like Shivam rightly pointed out, what is really important, we believe, is payload for the Indian market, because by increasing payload, we can split the cost per kg by a higher, higher number of kgs, which ultimately means that is cheaper to operate.
Like to discuss about the battery technology involved. Like this is a proper electric air taxi. If you could throw some light on the battery technology behind it,
Sure.
the drivetrain basically.
Yes, the current battery technology that you see in EV cars, scooters, trucks, that is at the half of the energy density that what we are using. It is very energy dense battery, and it's not just that, we are also able to charge that entire aircraft from 0 to 100 in 25 minutes, which is something that we are very proud of, and that is something that is intellectual property that we are still building at Sarla Aviation. It's completely all electric. There is no hybrid option here right now. Like Rakesh mentioned earlier, it's like there are multiple batteries here, so there is a backup of a backup of a backup. So it's very safe in comparison to helicopter or any other aircraft that you see today. And so there is a redundancy at a battery level. When you look at the powertrain as a whole, we also have a 6 motors working in a hover condition, unlike a helicopter where there is a one large motor and a propeller.
Would you like to share some specifications of the vehicle? I mean, how much time does it take to charge? What's the flight time? The specifications and features of it?
So charge time, I think, is 25 minutes. 25 minutes from 10 to 90%. We fly 165 kilometers with that battery charge, which is operational range. So that's the range that we will actually, or that we are aiming to actually fly. And we fly at 250 kilometers per hour.
What's the charging setup like? I mean, is it what's the charging station like? Is it what kind of setup it is basically?
So it's not typically the what we see for the automotive industry, but we would like to. So globally, nobody knows what kind of charging standard we need to use for eVTOL. So every company is trying to help the government to understand what works the best. And in India, since we are the only company, we want to do that while working with the government, and we have a good research and data to share with government that what works the best for them.
What stage of development is the product right now?
We are at the TRL level 4-5, which is a very good stage in a 1 year, where TRL 4-5 basically means you had a concept, you had it prototype, and you already manufactured manufactured it, and you have a little bit confidence. So anything aircraft without certification, we are at that stage already.
And what kind of certifications are you looking for it? I mean, DGCA certifications, and what kind of category does this vehicle fit in?
Yeah, that's the first time in I think over 30 years that the DGCA actually has to create a new category of vehicles, which is super exciting, and I think a great. I see mostly the opportunity here more than a challenge. It's a challenge for sure, but the opportunity is to build a category that really benefits India first and puts India in the focus, because we've seen that the certification types in the United States are coming along now, and now it's a question how the DGCA wants to tackle that, and I'm fairly confident that the Ministry for Civil Aviation, our leadership here, has a great understanding of the kind of benefits that this technology holds. So we're very happy in how we got to work with them so far.
By when can we expect this to see flying in our cities? You said starting from Bangalore, right?
Yes, starting from Bangalore, and we are aiming for 2028.
2028.
Yes.
And you said the propellers, first they give downward thrust, then they
Right.
lift, and then they turn. Could you like to explain how does that work?
Sure. So if you look at it from the top, we have 6 propellers and 6 engines, and out of that 4 are fixed and 2 are tilt rotors. So all at the end of the wing, if you can look at there is a end of the wing, there is a tilt rotor. So it stays in this configuration while taking off. It takes off flat like a helicopter, and when we achieve a particular height, it starts rotating forward, and it goes from a helicopter configuration, let's say, to a plane configuration. So it changes its type. If you can, it's a polymorphism kind of a thing. Like if it goes from a helicopter thing to a plane in the air, and then it goes forward with the help of a pusher.
So helicopter to plane, that must benefit the speed of the flying, right?
Sorry, can you repeat?
I mean, helicopter flies slower than the plane.
Yes.
But since this sort of transforms it from helicopter to a plane, so the speed must be like really high for this vehicle, right?
Yes, it's a 250 kilometer per hour, and it's the wings that you see right now. It makes really easy, and it differentiates us from a helicopter kind, because helicopters don't have wings and they are always utilizing the maximum power to stay afloat in the air. But when we go wing borne in the aircraft from hover to forward flight, we actually generate a lot of lift from the wing. So the energy consumption from the battery is also very minimum.
Also in the presentation, you guys mentioned that this can land on the smallest of places. Like, please, how does that work?
So currently we have chosen these 15-meter wingspan because that's the typical radius that a helicopter blade has. So helicopter blades, helicopter landing pads that are there vary from 15 to 30 meters in diameter. So this is the kind of infrastructure that we're thinking about right now that we want to utilize. Most of the places, in organized places like here, for example, at Bharat Mobility or at the airport, hospitals, offices, corporate offices, IT parks have helipads already, so we can connect these points very seamlessly with each other. And then as we move forward in time, we want to bring this the footprint, the actual physical footprint down. But I think first we have to establish this mode of transportation, and that's what Shunya is for, and that's why we call this Shunya, because it's the starting point.
So you're saying that the final product will have a smaller footprint than this?
No, sorry. Not the final product will have a smaller footprint, but just like the first car is not like the last car, also this first flying taxi is not like the last flying taxi. So I think as we move forward in time, there will be other models that we'll see coming, and I think that the tendency would be that the footprint will be
The
reduced.
portfolio, you mean?
Yeah.
Perfect. And last question. I don't know if you'll be able to want to answer this one or not. What kind of a price tag you planning to put on this thing?
So we're not putting a price tag on this thing, but we are aiming to make this as affordable as a premium taxi ride in the beginning, and then come all the way down to an auto rickshaw ride over the long run. When we fly, like by the time that India will turn 100 years old, we want to make sure that everyone flies this every day for their everyday commute at virtually no cost.
That's amazing. And what can be the acquisition cost of the vehicle? Any idea?
That's not something that we're looking at for now, and that we want to comment on.
Thank you so much. It's been nice one.
Thanks so much.
Thanks for the time.